f of x equals 1 over x, and what is its range? So we want to know all the possible x values that you can input into this function without it being undefined or non-real. And we also want to know all of the possible outputs of the function. So first of all, we can plug anything into this function except for 0, because if we plugged in 0, then we would have an undefined result. So the domain in interval notation would be negative infinity to 0, not including, and then from 0 to infinity. So we have a union here. The range, though, can be anything also except for 0. And that's because you have a constant in the numerator. When you divide by a variable, that can take on any number except for 0, of course. And if it's a negative number, whether it's a small negative number or a large negative number, when you divide it by 1, it's always going to have a quantity other than 0. And also if it's positive, it'll have a quantity other than 0. So the only thing that can't happen here is 0, because you have something in the numerator, and when you divide something by something, you still have something. You can't ever take something and divide it by something and then have nothing. We have a range that is also from negative infinity to 0 and 0 to infinity. Number 2 says identify the graph with the domain from negative infinity to negative 6, union negative 6 to infinity. So what this tells us is that we cannot allow x values to hit negative 6, right? So that means there must be a vertical asymptote through x equals 6. So let's figure out which one of these has an electric fence through the value x equals, well, that's negative 6. So negative 6 would be on this side, right? And clearly you have a value somewhere between 0 and negative 10. Looks like negative 6 could be on there. Here it looks like there might be an electric fence right there. I'm thinking it could be B. It's definitely not C, because again, if you draw a vertical line on the left side of the y-axis, it looks like there's values. You just zoom in here. Let me use a different color, perhaps that'll make it more obvious. So 2, 4, 6, right? So right through here, but there is definitely, the function is going through and having a point at x equals negative 6. 2, 4, 6, up, nope, that's a problem right there. So the only one that seems to be a candidate, 2, 4, 6, negative 6, even though it looks like it's touching, that's asymptotic behavior where the function is going towards positive infinity instead of crossing over x equals negative 6, and going towards negative infinity instead of crossing over x equals negative 6. So the answer is B.